kick it off. So thank you for joining my talk to talk about microservices. 4-year journey on what I've learned. So before I kick it off, I want to jump into a bit of an introduction and provide some context. If you Google lessons learned doing microservices, you'll come up with a lot of blog posts. A lot of those blog posts depend on the context, the team, the skills, the company, the problem they're trying to solve. So I want to provide you some context on where I'm coming from. So who is this talk for? Who did I write it for? When I started the journey with my company, essentially I tried to leverage as much experience as I could beforehand. I've written this talk for anyone that's essentially on the journey, is going to start the journey or is considering going on the journey. So it's my way of kind of paying it forward because I tried to leverage their pain and things they learned, and I want you to leverage mine. The aim of this talk is for you to walk out with value. So I've tried to cut out as much specific detail in terms of specific detail for my context, for my company on what we were delivering on our journey. The aim for this talk is to provide you value so you can take some shortcuts and you can really become more effective. So working with 8 development teams, there's around 50 to 60 developers. I collaborated with the CTO, but also all the tech leads, and I've tried to gain all their lessons they've learned and tried to generalize it so you can get some value out of it. So hopefully that will be effective. The lens I'm putting on this is also very important. I'm not doing it from a developer's perspective in terms of code. I'm doing it more from a higher level perspective. So my position was, even though I joined the company as a tech lead, my position ended up over the 4 years, essentially working with the 8 tech leads, trying to focus on alignment in terms of strategy. So I saw a lot of the pain and the problems teams were facing, different teams, different identities, different ways of working. So that's the lens I'm going to put on this. This is a relatively high level. So questions at the end. I'm going to leave about 10 minutes, hopefully if it all goes according to plan. For questions, we can chat afterwards, and if they need more detail, we can chat offline. All good. So very, very quickly, a bit about me. 20 years of software development, mainly web. A bit of a plug, I've got a bunch of courses on A Cloud Guru and Pluralsight. AWS is my passion, so it's something I like teaching about on DynamoDB, CloudFormation, RDS, Aurora Serverless, that sort of stuff. But as a full-time job, I love working with product vendors, and you kind of sense that out of the talk when I talk about product teams and product owners. I like working with product teams. You can just change a product to talk about the business, to talk about whatever you're building, whether it be consulting or in-house development. I like helping product vendors scale, and so I see time and time again technology kind of being a weight in the company, holding it back, legacy, technical debt, whatever you want to call it. I like to help product vendors scale, so innovate and scale their company, so technology is an enabler rather than a weight to the business. So moving on, let's get into the talk. I'm going to take you all on a journey. It's a 4-year journey, as the title indicates, of microservices. And we were on this journey of monolith to microservices, like the typical journey microservices go on. The first lesson is going to be starting off before we've deployed the first microservice. This is more about we've realized the journey we're going on and the sort of questions that arise when we kick this off. The next lesson is going to be when the first microservice hits production and the things that we learn. The third one is going to be a few microservices out. So we've got half a dozen microservices out, a couple of teams using it, and what sort of frictions did we feel? The fourth one is 3 years down the track. Almost every team has a couple of microservices out. We've got 10 to 20 microservices out, and the sort of things we were feeling with 8 development teams all trying to work together on one platform. Even though each development team had their own product, we're all within this one monolith and one platform that we're working towards a greater goal. And the last one is going to be focusing on hindsight. When looking back on the journey, what would I have changed? And what are the things I didn't realize when I was in the detail in the journey? So that's how I'm going to break it down. The first lesson, kicking off. So no microservices hit production, we're going to, we know what journey we're going to go on. We know the monolith, and we've picked the piece that we're going to build. So the first piece that hit us pretty early was investment. Microservices take significant investment to get off the ground. And the angle I'm coming from is, well, obviously we're on this monolith versus microservice journey. In a monolith, you tend to be in this fixed world, right? The fixed framework. So you've got a data store or data stores. You don't need to rebuild those. You've got a vertical slice. You've got your front end. You know what you're using for that. Or you might have various technologies, but when you're building a feature, you don't need to resolve it and investigate those sort of options. You've got your backend APIs. You've got your data access layer. You've got the bulk of it sorted. You might add in, hey, we need to upgrade something, but technically the bulk of the questions and the architecture is solved. Whether it's good or bad, you don't need to worry about it when you're building out a new feature. That's not the case when you're kicking off the microservice journey. It takes significant investment to get any of these up. Now, it really depends on your culture and the way you want to work on building out these microservices. It might just be the initial pain in terms of the first microservice, we've got to figure out all these things. Or it might be every single one, depending on your teams, your culture, how autonomous they are. But the sort of things I'm talking about is the technology stack. Are you going to use, for front end, are you going to use Vue, React? Are you going to use, or just do MVC? What's the front end going to be like? What's your style sheets? Are you going to leverage Bootstrap? Are you going to leverage .NET in the back end? Then you've got your data store. And this is probably the biggest curveball that I noticed. So it's not just the difference between picking SQL Server or Postgres or Elasticsearch or DynamoDB. It's not about those. It's about how do you get a production-hardened data store. So this is also about picking the right data model. It's also about how you're going to host it, how you're going to do re-indexing, how you're going to handle the disaster recovery. So if a developer accidentally deletes data or a table, what are you going to do in terms of backups? Are you going to do dry runs in terms of something goes wrong, how quickly can we get back online? These are the sort of things that, after a decade of a monolith, or 2 decades in our case, you kind of have it solved. And we don't think about it very often, but a data store can be a lot of upfront work to figure out how all these pieces are going to work. You've also got your project and code structures. Most people in this room would be developers, and we all have an opinion on what sort of structure we want. So what sort of testing libraries we're going to have, how we're going to break up the code. Your CI/CD tooling. So this also depends on the infrastructure, right? So passing your project and your code into continuous integration, there's a whole bunch of tools on the market, whether you host it yourself or SaaS CI tooling, like Travis CI. What are you going to use? How are you going to deploy it? Are you going to deploy it in the CI tool, just send it out to AWS, or are you going to use something like Octopus Deploy? And then that depends on the infrastructure. Can they support how you want to deploy? So there's a whole bunch of questions that start arising before you've even spoken about the problem domain here. And messaging and API calls. You're at this point, you've got a monolith and you've got a microservice. You probably want to talk between the two. How are you going to do that? And that can be a massive piece of the puzzle. But there's many more, but essentially I'm just trying to give an indicator of these are the sort of questions and areas you might need to invest. So let's say we have to even solve 50% of these. We could be talking about a half a dozen size developer team spending a couple of months on figuring this stuff out, if you decide to pick off each one. And there's more than this. So it requires a significant amount of upfront investment. But here's the catch. You don't have to do it up front. There's a couple of ways you can do this. So I've been lucky enough to go on this journey with a couple of companies, and I've experienced 2 models. The latest one was invest as you go. So as you pick up each project or initiative and you build out a microservice, you figure out which areas you want to invest in. So you go, obviously you can't ignore the project or code structures. Maybe you figure out your data store, or maybe you just use the monolith one in a separate database or a separate schema. There's trade-offs. But you pick your battles and you don't invest in everything up front. And then the next microservice goes, okay, there's pieces of the puzzle we've solved, and there's pieces we still need to figure out. So you invest a bit more and kind of mature that story. So you get to the point eventually, a year down the track, where a lot of these pieces are solved. That's one way to go about it. The other way is investing up front, which is, to be honest, my preferred method. And it sounds a bit scary because we all try to be agile and we try to do it at the last responsible moment. But investing up front has a few benefits. And I'm not talking about, hey, code up your domain before talking to the business. It's more about there's a large amount of foundation that doesn't really get changed between domains. And I'm talking about things like potentially your data store, like 95% of your microservices probably just get away with a relational database. Your code structure in terms of your project structures, how you're going to do UI, how you're going to do user validation, how you're going to do error messages, how you're going to do DR for those databases. A lot of these things don't change between projects within a company. You can figure it out up front, but they do take time. They take a bit of time. So it comes down to what works best for you. If you're a startup, you probably don't want to spend the first 6 months trying to design all these pieces because you just need to get the thing out, right? In the first journey that I went on, this is almost 5 years ago, we decided to spend 6 to 9 months investing up front. The business brought us on board for this journey, so we had business buy-in straight off the cuff, but it was the best decision that we made because as soon as we were able to deliver on those pieces, we were talking a handful of sprints to churn out each application and domain, each service. So the business knew what they were getting. In 6 months, they would end up with X, and then we would speed up after that. Whereas if you invest as you go, it can be quite a bit trickier because you've got to be clear with your stakeholders, which could be your business, your users, your product team, your developers. You've got to be clear on the approach you want to take and the expected impact. So if you're going to say, we're going to invest for 6 months, but you're not going to see any value for users, but what that's going to do is speed us up twofold when we're moving forward after that. Business can understand what the journey they're going to go on. Versus if you're going to take it off as you go with each microservice, you're going to have a bit of a challenge in terms of, hey, each microservice is just going to take an extra couple of months because we're continually investing as we go. So it's very important to be clear in terms of expectations, because if you're not clear, I've seen developers confused. I've seen developers say, hey, we need a data store, so we need to solve all these problems, and these problems can take 3 months to solve, right? How do you set up a DR process for a data store you have no skill sets for? You've got to go on training. You've got to figure out how it works. Then you've got to do dry runs. You've got to write up plans if something goes wrong at 2 a.m. And if you're not clear within your team, within your business about what you're doing, and they're expecting a feature to be out in a couple of months, there'll be a misalignment there. So it's very important to be clear how you're going to kick off this journey. So investing up front or investing as you go. I've been lucky enough to do both, and I've seen investing up front work very, very well. It depends. There's no silver bullet here. But that's the first lesson we learned. How do we want to start or kick off the journey? The second lesson is about culture and talent. And we all understand that microservices has a culture shift. It's been talked about a fair bit, but I want to take a slightly different lens on it. So we know there's culture shifts. There's many different models, whether it be Spotify, Netflix, Amazon, they all kind of follow this. They talk about this culture change that's required. Your own company and your own culture will be different. We followed the you build it, you run it sort of model. So the team is solely responsible from idea all the way to value for users. So the things I'm really trying to focus on here, things like continuous deployment, right? From a technical perspective, a commit in master will go straight out to production. Takes some getting used to for developers. So whether it be this task or story that I finished, is it feature complete, ready for users to use? Or do I need to do a dark release? Do I need to have it toggled off as a feature and then wait for all the other pieces to come in before I switch it on? Or do I have enough confidence to get it out the door? Do I have enough automated tests to say, hey, as soon as that hits master, I'm ready to go? That takes a fair bit of process and takes a bit of technical adjustment within teams, within product, to get used to. Users need to get used to it. That one click can change the UI. That continual change can happen anytime. There's no version on the software, will need to get adapted. And automation is the next level, right? So we're talking about not just automated test suite, we're talking about infrastructure. When you've got microservices, you're probably going to have a few of them. And the last thing you want to do is start setting them up manually. So then you've got your development team automating the infrastructure through whether it be scripts or infrastructure as code. And then if you went to James's talk about evolutionary architecture, we're talking about continuously deploying your infrastructure as well, taking it even further. So that takes adjustment, getting used to. What sort of infrastructure are you going to have? Development teams getting used to that, but also being cautious of when you change it. I've had teams say, in AWS, we've got a SQS there, and someone just wants to rename the queue. But what really happens is it'll delete the queue and create a new one. If that's live in production, you're going to lose data if that happens. So just being aware of, hey, I'm just merging this change in, could have significant impact. So doing it in stages is important. And I guess the pieces I'm talking about is this end-to-end ownership. You build it, you run it, is a big piece of the puzzle. So it's not just about developing it, the backlog, the product. It's also about supporting it. So if you're going to do the you build it, you run it, the team owns it completely, who in the team's going to get up at 2 a.m. to support it when it's down? If you need to, obviously. Are you all going to have pages? What about Friday night when everyone's down at the pub? Who's going to come back? And you probably don't just want one person, you probably want 2 people. Especially if you need a code change or something, right? Or roll back. What's going to happen? What's the process? Do they have enough permissions to change your infrastructure or fix what's required? Then the security. What about the security of it? Do they know the things to test for to make sure it's all locked down and you're not opening a big hole up? There's a disaster recovery. What to do? How to do it? What to communicate? If something goes down and you've lost a table of data and it takes 5 hours to restore it, who do you need to communicate to? Do you need to communicate to the C-level, your users, the product team? And the business processes around that. There's server maintenance, patching, upgrades, re-indexing, downtime. People have got to be comfortable with this. Telemetry, usage. There's a lot of stuff in this end-to-end ownership. So we like to think that when we build something, you can run it and just the support side of things, but there's a lot of operational concerns we need to think about. And you kind of learn this over time, right? Our first microservice, it went down for a little bit due to a bug in our deployment. So what happened? What's our process in terms of triggering that? We had alarms go off, but who reacts to the alarms? Who's watching the alarms? And they're the sort of things you kind of learn. How do you mature to a model where you can build it and run it? Where it's not a centralized team, operational team, but it's each development team can do this on their own. And people know who to call. So let's talk about the team very quickly. From our perspective, we had a full spectrum team, which meant you had a tech lead, seniors, mid, and juniors, the full spectrum. Now, the people who would be comfortable with the range of these techs or large percentage of these techs, those tasks would be towards the senior side. You can have mid-levels and juniors comfortable with it. There's a lot of them that are. But the crux of it is you don't want bottlenecks either. You don't want your tech lead the only one who can support it if it goes down. So you need to start sharing this knowledge. You need to start learning. You need to start going on training courses. You need to start doing dry runs. You need to start talking about these cases when something goes wrong. How quickly do we need to respond? And you need to share that knowledge because you can't have single point of failures, right? So what I'm trying to get at is there's not just technical investment required, but there's also people and talent investment required. And it's not investment just in terms of, hey, we'll spend a month learning this. You got to enable an environment that's safe to fail. It's okay to fail. You need to be an environment which doesn't have strict deadlines. You need to get this out by the end of this sprint, otherwise the business loses $1 million. Because you're learning. That's not a great way to enable a safe environment. There's a lot of cultural shifts that need to happen to really enable that you build it, you run it model. You need to have empathy for that journey. And to be honest, I haven't met a lot of tech leads and seniors who are very comfortable in that space, end to end, who have not done microservices. It takes time for almost everyone to get comfortable there. And the last piece, this has been spoken about a bit, so I won't delve too far into it, is the distributed systems nature of it. Distributed systems is hard, right? We know the first rule of distributed systems is don't do it. It's hard. So if you're going to buy into microservices, you're building this complexity straight off the cuff. I'm not saying don't do it. All I'm saying is make sure you're going to get more value out of it than the complexity you're buying into. And so for the room, I guess to make sure everyone understands the complexity I'm talking about, let's assume there's two systems, right? It's service A and service B. They communicate over a network. So let's say service A here has an array, and service B needs this array. So the simplest way to send that array over to this system would probably just be an API call, right? So let's say we build an endpoint on service B, and then we send it over. Awesome, it's sent over. But then what about if there's an error coming back? So we'll retry, right? Standard cloud pattern, and maybe have a circuit breaker around it. So we'll retry a couple of times, and then will succeed. But then what if it goes down for maintenance or whatever it is? Or goes down for a day? What are we going to do if there's a whole bunch of requests that just start failing? And then do we start building up on one side? Okay, maybe we can put a queue in the middle. So we then start throwing these messages in a queue, and they'll get picked up and consumed whenever they feel like. But then this array keeps changing because, users are talking to it. So what information do I need to transmit? Do I need to transmit what changed or the whole end state of array? And then it's getting on the queue, but the orderers are switching out because most queues don't respect ordering. So what am I going to do on the other side to make sure it always ends up in the right end state? These are all complexities that I talk about when you're doing distributed systems. And so when you're going to have dozens of microservices, these are the sort of questions that are going to come up over and over and over and again. And so your senior staff might be quite comfortable in handling these, but the whole team end-to-end might not. And that's okay. This is a hard concept to solve. But you also don't want to reinvent the wheel every time. You don't want every single API call having a sprint to figure out exactly how to reliably deliver information. So this is going to need some empathy. And it's going to need some respect because the last thing you want to build is a highly distributed system that's unreliable. It's just support's going to explode and your users are going to get frustrated. So the lesson I'm trying to get at is we've got microservice out and you just need to be empathetic towards the talent and the culture shifts that are required by developers to support this end to end, to build it, but also support it. You need this environment which is safe to fail. You need an environment which isn't tight deadline driven. They need to learn and they need support doing that. And that's very, very important. This is a lesson that I haven't read anywhere else. And so I wanted to talk about this because we kind of just logically came to this solution within the company I was working for. But it gave us a huge amount of value. So I'm hoping this can be useful for you as well. So we're doing microservices for a reason, right? We're doing it because the monolith or somewhere we're coming from is slowing us down. It's causing us pain. But the catch is it's hard to avoid integrating with the monolith. That's where the application is. That's where the platform is. So when we build a microservice, it's typically not going to be a standalone service, right? It's going to have to integrate. Users log in there, then they'll come over to us, and then we'll have to send some data back. There'll be some level of integration. In the years of me doing microservices, I don't think I've built any microservice that's had no touching the monolith. It's always had to integrate somewhere, whether we bootstrap it at the start or we send the data back at the end, whatever it may be. But we know with integration, we integrate early and we integrate often. That's the way you reduce that pain, but it's always painful. Here's the catch that no one talks about. That integration to the monolith comes at a cost, and a really big cost. And that's something that needs to be questioned. It's very hard to avoid it, and I'm not going to say you should avoid it, but you should definitely bring up the cost of doing it. Let me give you an example of something that we experienced at PageUp. So we are, in our monolith, we deploy the monolith every day. So typically in a release train, every day, every morning, we'd deploy it. But it took 2 days for the code to get out to production. So it would go through a staging environment and go out. So we'd have a sprint and we'd plan out, okay, at the end of the sprint, we would have a demo. So in the first week, we kind of build our microservice part and we get that out. We're deploying multiple times a day. It's all good. And we go, okay, second week, that data we've generated, we've got to send it back now. So on the first day, we kind of build out the code. And the second day, we kind of deploy it. 2 days later, it's like Wednesday or Thursday, and we realize there's a bug or it doesn't work. And then we try and fix it and deploy it, but we've run out of time. You can almost put down that sprint, 50% of that time was spent on the monolith slowing us down. Just that release process, just waiting. Even if it's one line code change, you're tied down to a 2-day cycle. Now, I'm not saying the monolith will always slow you down. Sometimes I've heard monoliths being deployed multiple times a day, but it comes at a cost because you're moving away from it, right? So you need to be aware of this cost, and you need to talk to your product, and you need to talk to your users, and you need to talk to developers about this. And is there any way to minimize it? So this is what we did. That was our monolith, and we've got a bunch of microservices. So imagine we in the .NET house, so we had a Visual Studio solution. What we did was we grabbed our API project and all its dependencies, so business layer, data layer, as well as the database, and we continuously delivered it. That doesn't mean each commit goes out to production. That means it was ready to go out to production. We'd have to click a button and it would be sent out. So we grabbed that slice and we deployed it on separate machines. And that kind of sounds really scary because what you can have is new versions, new business layers out in production and the old ones out in production as well. Because obviously these dependencies are all shared, right? The database gets deployed live when the production system's being used. But with all those constraints and those scary pitfalls, it provided us a massive amount of velocity and value, way more than the issues it caused. I think in the 4 years we had 1 or maybe 2 issues, but we were able to also roll it back really quickly. So what this enabled us to do was just taking a slice of it and making it easier to deliver faster, enable these guys to move a lot faster. So those sprint demos we kept failing to meet and losing business confidence on, we almost sped up tenfold. But take it a step further. Can you go standalone? Now, unfortunately, I wasn't able to achieve this, but just prior to leaving, we were in discussions of could we build a standalone application that didn't integrate with a monolith? Could we bootstrap it with the data and just leave it there? And so make it standalone. When we went through the estimation process, we cut off a significant percentage of the estimate. And I'm talking like 40 to 60% of the time and effort. Right? This is significant. If you talk to the business about this is what you could save, it's worth talking about the trade-offs. What would you lose? Hey, you might lose reporting. Is it worth it? it's worth a discussion. So the lesson I'm trying to drill home here is each of these tethers comes at a significant cost. And most of the time you can't avoid it. But see if you can minimize it, see if you can reduce it. It will definitely save you. Teams and capabilities. This is a big one. This is something I think that caused us a lot of pain, and I'm hoping most of you don't experience that. But before we jump into this, I want to define a term, because I mean something very specific when I mean capabilities. A capability is an API-enabled reusable building block. Now that could be a NuGet package, an NPM package, that could be a microservice. That could be an AWS service. They're all API-enabled. Doesn't mean you have to build it, but they're reusable. And that's a capability you're able to leverage to move faster. So some examples of how we distinguish capabilities internally. We'll have foundational capabilities. So it could be your data storage, how you do multi-tenancy, how you do backups, your continuous integration tooling or continuous deployment tooling. It could also be just a microservice template. Hey, instead of recreating and doing .NET new, you can just clone or fork this repository and you'll have the basic structures, your test libraries. You could have YAML files that execute your continuous integration steps. It saves you potentially a sprint. And then you've got your next layer, which are your platform capabilities. Things you could open source, but are general capabilities that you need across any application. Things like authentication, security, forms to accept data input from users, workflows and message bus, right? And then there's your last capability, which is your domain, the core business, things you wouldn't open source, your business. So open source examples from PageUp, serverless microservice template, and API fuzzy serializer. So this is, the last one's a library, an example of a capability, which would be, we had a lot of frustration integrating with, clients integrating with our public API. And the examples I can give you are, we add a non-breaking change, we add a property to our API, our response, and it causes the client to break. At this point, you get on a call with the client and you have a discussion on the definition of a breaking change. But this, it's an extension to Newtonsoft, anyone from the .NET world. Basically, it randomizes the properties being sent back, but it also adds random properties to it. So they can't really tie and strongly couple themselves to your API. It forces them not to, because every request will change. And that's all that does. But there's sort of small capabilities that every public API needs. And this happened to us a couple of times. So just examples. If you want to get more capabilities, you can check out the PageUp repository, and there's a whole bunch we've open sourced, but I'm just trying to give you an idea of what a capability is from my perspective. Now coming back, teams and capabilities. A lot of people talk about microservices and having autonomous services and autonomous teams. But I feel like people have gotten carried away with autonomous teams because that's not the end goal. Like you can have autonomous teams, but that's not what you're aiming for. That's not the end state. What autonomous team is really trying to talk about is you want value delivery without bottlenecks, right? You want teams to be able to get their stuff done and get value out to the users without being tied down and slowed down through like change boards and approval processes or DevOps teams. Can you set up my infrastructure, please? So you want teams to move fast. That might be autonomous teams, that might not be autonomous teams. Having been through 4 years of autonomous teams, I'm not a big fan of it, especially because I was on the outside of it. I saw all the friction, all the pain that caused. But if you are doing autonomous teams, you need to make sure there is strong alignment between them. People don't like to say dependencies because, hey, that's not autonomous, but you need to make sure they're all pushing in the same direction and they're all considering one another. a full-time job. Unfortunately, this was my role, and there were a few of us working in this space, but getting strong alignment with 8 development teams is hard, because you're basically talking about communicating to multiple different teams, different personalities, on why they should do something in a different way than they thought. Because autonomous teams tend to focus on their product and their KPIs and what they're trying to measure. So a story of where this went wrong for us. This is painful. So on our first microservice, we decided not to invest in the event bus or a message bus, whatever you want to call it. We decided to just do an API call. So that's fine. We thought, okay, if it's not going to work, we'll roll back and we'll invest a bit more. So we just did an API call to send the data from our microservice back into the monolith. And it was fine. It worked. It caused us a couple of issues, but we were able to absorb that. It's fine. A couple of support tickets in 6 months is fine. Then the next team picked up a microservice and go, hey, we need to get some data out of the monolith. And it's going to be a huge amount of data. It could be bulk. So let's put a queue in there. So they put a queue in there, and they sent a whole bunch of events over a queue. That's fine. They did that. Another team picked it up, and they said, hey, we've got these messages that we need multiple consumers for. So they put SNS in front of SQS, from anyone with an AWS background, and they did pubs up, right? Cool. Then we had one team saying, hey, we need feeds. We need to be able to replay these events. So they did it in DynamoDB. They threw all the events into DynamoDB and they read them out. And they projected them out also using Lambda. That's another way to do it. And the last attempt was leveraging SNS, SQS, and S3. So S3 being the permanent storage for these events. And we ended up having, I don't know how many I mentioned, 4 or 5 event buses. That's not good alignment. That's a lot of waste for a company. Like, this was one objective we were trying to fulfill. Each team had different requirements of what they needed, whether they needed ordering or whether they needed persistent events and replayability. But at the end of the day, it's one responsibility of delivering this piece, and we didn't come together to solve it. Each team was autonomous, and they thought, we'll solve it better than the last, and they built their own. So autonomous teams have their benefits, but they can cost you a great deal of over-engineering. Really, you've got it. It's a full-time job to make sure they're aligned. So be careful of the model of teams that you're going to be working with. So to bring it back to capabilities, I found capabilities to be a really good way to communicate where to invest and the building blocks you really need. Teams should align on capabilities. And you need to lift teams, tech leads, make them aware of the greater good. You're all in one company. You're all working for one goal. You need to make sure if someone builds an event bus or a message bus, or it's for the first iteration, or it's security, or it's permissions, whatever it is, it doesn't matter. The other teams take it on and mature it more. Or they have a discussion up front of these are our requirements, and this is our requirements, and this is what we'll do, and you can take it from here. Whatever it is, they need to come together and they need to align well. And it's absolutely critical. So this is the 4th lesson that I learned in terms of every team's got their own microservices and they're all autonomous. And that's the sort of pain it can cause. I've seen a lot of smaller companies, like only 1 or 2 teams, fairly large teams, but teams, they do this relatively well. So this will probably be a bigger issue the larger the company gets. The last one, respect the architecture. And this is after we've put about 10 or 20 microservices in production. This is hindsight. What could I have done differently? If you take one thing from this talk, let it be this. This is the most important phrase that will define your success. Capabilities will define how quickly you're able to prove to the business this is the right architecture. capabilities, the reusable building blocks, is going to enable you to move faster and prove to the business you've solved the pain you're trying to get away from. Because that's what you're trying to do at the end of the day, right? So if you're going to remember one thing, just this: how you're able to leverage each other and build out those capabilities, those reusable building blocks, is going to define your success. But it's not that simple. So we did try and focus on capabilities, and we had discussions with a technical leadership group with all the tech leads coming together on what are we going to do, how are we going to build it. And after a couple of years, we realized what we were doing wrong. And it's called the Scattergun Approach, where every feature that we build out, we'll build it well, and we'll invest properly in it. But the catch is, product and the users and the business, the ones asking for the features, don't think about how focused they are. They don't always think about what you're going to get back from the architecture. So let me give you an example. Let's say we've got to build 3 features in this 12 months, X, Y, Z, right? And on the y-axis, we've got the amount of investment or the maturity of the capability that we're going to build out. So feature X, we build out 1 capability. Feature Y, we invest a little less and get it out to a certain point. And then feature Z, we invest a bit more. But the catch is, these capabilities can't just be plug and play or reusable straight off the cuff. There's a certain point where they can be, where they literally can say, hey, we've got a forms framework which can accept data input. And that can just be used across the whole system. It's got all the features that you need to use it. So it comes to a point. So if this is how your 12-month looks in terms of having 3 capabilities, what the business has actually felt is a lot of investment, a lot of pain, but you still don't have a return. You haven't actually moved faster. So there is a solution to this, but it's very important to be aware of where you want to invest, where you want to refactor, what you want to rebuild. And everything rebuilding, every feature you touch should be a microservice now, can be very dangerous, because that's exactly what we did. So this is how we solved it. So product companies, once again, if you're working in a different space, you'll have an idea of where you're headed. Get a product roadmap. What you're trying to do or what you're aiming for in the next 12 months, 24 months ideally, and figure out the sort of features or the direction you're going to be focusing on. And really get the company to narrow it down, not saying, hey, we want to do everything. We probably want to focus on this vertical market where security is very important, and maybe this vertical market where user experience is more important. And what you do is you figure out, you pick what's most important, and you figure out what capabilities are required. So 40% of them require search, 77 workflows, message bus 61, and you essentially weight them. And what you end up getting is a set of building blocks based on the importance of where the business wants to go or where the product wants to go. Now, each company is agile, so that will vary. That's okay, but at least it's a best guess. You get a direction that everyone can align to. And then the next step is to align your teams to it. Make sure they get their head up and look at the bigger picture. This is what we're doing as a company. And then you figure out, okay, all our initiatives, all the projects need authentication permissions. There's a big pain point here. So let's really invest in this space. Let's get this capability out in the first 3 months, because we know we're going to speed up tenfold after that. And then get teams aligned to this. Even if it doesn't directly align with their project or initiative, but it's for the greater good of the company, get them aligned to this. And what you'll end up with is a capability roadmap which aligns with your product roadmap. So you have a technology strategy as well. And so everyone, developers, stakeholders, everyone will get to understand what each investment means and what it's going to return. And you can start measuring yourself and holding yourself accountable to, if we spend 6 months on a message bus, what are we going to get back for it? We'll save 9 months on this project because if we built without it, it'd cause X. You can start having those discussions. You can start having trade-offs. And also the big benefit of this is developers start feeling connected to a bigger goal. So if the company says, hey, we need $30 million revenue, that's kind of like, yeah, developers don't care about that. But then when the product says, this is what it means, we need to grow in this market, and these are the features we need, and then you can assign some technical strategy that aligns to that, suddenly developers feel connected to $30 million. And that's a benefit we saw. And the other piece, in hindsight, was service boundaries. Service boundaries is a really hard, unspoken concept in microservice, I feel. Like what we normally talk about is, what's a microservice? Oh, it's a bounded context. What's a bounded context? Oh, you should read the Blue Book. We seem to abstract away core concepts for some reason. What's a bounded context? It's a logical term in this pattern someone's come up with. Not to put DDD down at all, but it kind of misses, it abstracts away what we're trying to optimize for. And Jimmy Bogard, if anyone saw Vertical Slice Architecture, spoke about this really well. He essentially did this. And it's called volatility-based decomposition. The same thing as vertical slice architecture. The software life is not, the cost isn't the development, that's just the first 12 months. The maintenance is what costs, right? So you want to optimize for that 10 years afterwards. And what happens in the maintenance is change. That's the complex part of the job. It's not when it's a greenfield, it's when you're changing it, when there's so many years of, and different developers changing it. So you need to optimize for that phase of the project. What that means is requirements are going to change. Change is going to be thrown at the architecture and needs to handle it. So you want to decompose your architecture based on the volatility or change. And that's exactly what Jimmy spoke about. Bring all the axes of change together and encapsulate them, right? And whether it be a class or a microservice, it doesn't matter. So let me give you an example. Let's assume we have 10 microservices and we need to change the permission model. So at the moment, our permission model is based on roles, 2 roles, right? Let's say admin and user. So the way we've built it is based in all our controllers, we've just gone if user is in role admin or if user is in role user. And that's how we do permissions. But then a year down the track, the company comes to us and says, clients are not satisfied with this, this permissions model. We need to be a bit more dynamic. We need to match their company hierarchy. So it needs to be a lot more configurable, okay? So however we solve that, we're going to have, the blast radius is our whole platform. All those if statements need to change. That's not encapsulated at all. That's changing almost every single microservice on our platform. The ideal would be we encapsulate that permission model and we change one service. And we just get that done, right? So you need to think about the areas which are going to change over time and for one customer and things that change between customers. And you need to start encapsulating those big changes as much as possible. And I feel that's something that you can measure, something you can aim for, rather than just using an abstract term of bounded context. Have you got a bounded context? Of course I do. It's correct. Optimize for change. It's very important. And I feel that's the piece that we don't speak about very often. Like, if I need to stand up 5 microservices just to get a change done, that's a significant amount of time, especially if I haven't dealt with those microservices before. Setting up, even if it's in Docker, setting those environments up takes a significant amount of time. And testing across those boundaries, that's not a couple of hours worth of change. You'll spend a developer a week doing that just alone. So the cost of change across separate systems is going to blow out. So encapsulating them is going to be important. And this is the recipe for disaster in microservices. The whole distributed monolith thing everyone talks about. If you haven't encapsulated change and you need to modify 10 microservices to get one change done, you've picked the wrong boundaries, which is okay because we all make mistakes, but it's just being aware of it and fixing it as you go. So instead of saying a microservice is bound to context, figure out what you're encapsulating within that boundary, the change. And that's a much better way to connect with developers when they're talking about requirements. And you can go to product and you can go to business and say, what's going to change over the next 5 years in this thing? What could change? And you start talking about the things that could change, prioritize them, and figure out how you would encapsulate them. And sometimes it's difficult, especially in a distributed system, because sometimes the data is all over the spot and it's not easy to move data. So then you start talking about maybe we need to make a sizable service here, which is okay. I'm not going to get into that argument of the size of a microservice, but I feel this is something that's not spoken about a lot. It's exactly what Jimmy was talking about. If you Google this term, there's a ton of content. This has existed for decades, this concept. So I do recommend, if you've never heard of it before, check it out. There's a lot of proven methods on how to get through down this path. And the last thing is remember your goal, right? You've decided, or you've been part of a decision to go down the microservice journey. That's a massive decision for the business, right? It's going to take a lot of investment, and it's okay to fail. It's okay to do it wrong. Just measure yourself, hold yourself accountable, measure. If you're not moving faster, have a retro. Figure out why, change something. Please don't keep going blindly, because the business will suffer. They pay our bills, right? It's very important to remember to test and validate what you're doing. It's okay to be wrong, but do it before your manager or the boss comes up to you and says, look, we're just going slower, we need to pull back. That's the worst, right? It's better that you detect it earlier. And maybe it's a small tweak, maybe it's just the wrong architecture. It's okay, but just hold yourself accountable. So summary, the 5 lessons I spoke about. Figure out how you want to go on the journey, how and when to invest. Whether you want to invest as you go or upfront. Be empathetic towards the culture and the team shifts required. It should be safe to fail. It should be safe to learn. People should feel safe. Hey, I don't know how to do this. Don't have single point of failures. It's going to require investment. Be aware of the cost of integrating with a monolith and really scrutinize it. Have discussions about this. Align your teams and your capabilities, making sure you're all playing on the same team, the greater good, and the architecture. So see if you can set up a capability roadmap that really aligns your business to your technical investment. It'll make the business feel a lot more engaged with the architecture, which rarely happens. And the service boundaries. Get your tech leads together and discuss about these volatility in your business. What could change? Map it out. And you'll be wrong. I'm wrong all the time. But as long as you keep going over it, you'll eventually start getting closer. And that's it. I think we've got a bit of time, about 5 minutes or something. Any questions?
Yes, we have.
Yeah.
You mentioned about upfront investments and pay as you go, right?
Yep.
So especially in agile teams, they don't do big upfront designs. So when you mention about investing upfront, basically I assume it's on the foundation capability, right? So without doing a big upfront design, you can't identify all those building blocks you need. So how do you manage that? When you do a minimum upfront design, you only know a few capabilities which you need to build. And in the earlier model, you can't build everything, right? Only you know certain capabilities you can build.
Yeah, good question. So I'll repeat the question. In an agile environment, it's not always easy to invest up front. You won't always know what to build and how it's going to turn out. So is that about right?
That's right.
So the both environments that I've worked in, both were agile. The thing is, you'll be surprised how much you could build. So the things you'll probably need, you'll need a UI of some sort, you'll need user input validation, you'll need a backend, you'll need APIs, you'll pick your front-end technology. React, Angular, whatever your taste is. Sometimes you do need to know the business domain, sometimes. But most cases, you can figure a lot of these building blocks out, your data store. So if you can solve 80% of those building blocks or have an idea what they might look like, but the way you build them out needs to be, rather than a framework, it should be more tooling. So teams can adopt pieces of these capabilities rather than having to buy into the whole thing. So they can say, hey, we'll take the microservice template, but instead of using SQL Server, we need Elasticsearch. So they invest in Elasticsearch, getting that capability, but they're still able to leverage as many reusable building blocks as possible. And so even both my environments were quite agile, we were still able to spend, I think we spent close to 9 months coming up with a lot of these building blocks, and it saved us a huge amount of time. So it does sound scary doing this up front, but let's be honest, a lot of us copy and paste code from our previous projects and reuse it, right? Being honest, we can reuse a lot of the stuff. But it should be okay for teams to move away from it as well. That's the most important thing. Don't make it a tight framework. Yeah, that's the way I would go about it. Yes?
In the event or story that you mentioned, didn't quite get what was sad about it, like the fact that people had to learn over and over or not reusing the knowledge. Because if they had different requirements, like how would you do it differently?
So how I would do it differently. The event bus story, I guess the real pain associated with the event bus story was we weren't maturing one investment. We were starting from scratch every time. And what that meant was the first microservice with that API call was still there. So we had almost 4 or 5 different ways of communicating messages or events between these systems. So if you needed to consume a couple of events, you might have to subscribe to different buses. So that's one point. But the other point was also understanding that each time a team realized they needed something, they would spend almost a couple of sprints trying to figure out how to build it, what are the concepts, and then trying to go about solving this, rather than leveraging what was already there. So it just comes down to teams talking to each other and saying, hey, we've got a solution here. It's not perfect, but if you could mature it, it'll help both of us. And being a bit more empathetic towards each other's requirements. So when you build something, figure out what requirements there are within your company if you're on one platform, and trying to build towards that, opposed to autonomous teams, I'll build to my solution and get it out. Because what happens is when a team gets to mature it, it brings everyone along with them, opposed to siloed solutions. I need to now rebuild my whole integration because there's another service bus over there. Oh, and its event definition is different. So kind of isolates each team, each product, each integration bit. So that was the pain. Yep. So I think we're out of time. Is that right? Yep. Okay, that's about it. So thank you all for your time.